Hi everyone and welcome back to my channel A in Economist. So we are continuing with our lecture on relations and functions, and let's start with this review question. State whether each of the following relation represent a function or not. So in the previous video we have discussed that function can be of two types. It could be either one to one or it could be many to one, right? So we need to basically identify which of the following represent one-to-one function or many-to-one function, and only those will be valid functions. So let's take a look at the first question. A has a mapping with Z, C has a mapping with X. These are fine, right? For each input you have only one output. But if you see here, B is an input which does not have any mapping, right? Any mapping in the codomain. So for a valid function you need to have for each X value a singular Y value. But here B does not have any Y value corresponding to that. So this particular case is not representing a function. Let's look at B. A has a mapping with Y, B has a mapping with Z, but C has two different output, right? C has a mapping with both X and Z. So it's the one to many relation and not a function. So this is also not a function. Let's look at the third case. Here this is a pretty simple case. For each input you have a unique different output, right? So it's a valid function, it's a one-to-one function. And if you see the fourth case, the first element has a mapping with this, the third element also has a mapping with this, the second element has a mapping with 4. So here what you see is that 1 and minus 1 are two different inputs but going to the same output. So it's the many to one function. So it's a valid function. So if you see, C and D represents function, but cases A and cases B are relations but not functions. Okay. Now let's move to the concept of domain of a function. Domain means the valid X values, right? Valid X values. So we need to find the domain for each of the cases. So let's do that. The first one says Y is 1 upon X. Now we know that the domain cannot have a 0 value, right? X cannot take the value 0, except 0 it can take any other values. So what you can write, X cannot be 0. So what will be the domain? It will be all the X values belonging to R such that X cannot take the value 0. Or what you can write, domain all the real values except the value 0, or there is another way of writing this, all the real values except the value 0. So these three are the possible ways of writing the domain of this particular function, right? Let me do the second question. It's almost the same question, but here X cannot take the value 2. If you put 2 here, it will be 0. So again what do you do? X cannot take the value 2. So the domain will be every real value except the value 2. And you can write this manner as well, right? Now the third question says Y is 1 upon X plus 2, X minus 3. The concept is again the same. The product cannot be 0. So there are only two values which makes this product 0. Either X is minus 2 or X is 3, right? You can put the values and check. So what do you write? You write domain to be all the X values which belongs to real number such that X cannot be minus 2 and X cannot be 3. Or you can write the domain is all the real values except the values minus 2 and 3. I hope this is clear to all of you. Let's do another question. Find the domain of the function. So the question is y is plus root over of x minus 2. Now the inside part of the square root should be greater than or equals to 0, right? It cannot be a negative number, otherwise this will be an imaginary expression, right? So this inside part has to be greater than or equals to 0. So we write x minus 2 is greater or equals to 0. This basically implies x is greater than equals to 2. So what can we write as a domain? All the x values which belongs to real number such that x is greater than equals to 2, or we can write domain all the real numbers such that x belongs to 2 to infinity. So both are correct, right? This is different way of writing the same things. Let's do another question. This question says y is plus square root of 2 minus x 4 plus x, right? Now again the concept is the same. The inside thing cannot be less than 0. So what do we want? We want x 2 minus x, this thing, to be greater or equals to 0. Now there are two possible cases which makes this expression greater equals to 0. First case could be both the expressions are individually greater equals 0, and there is another way, they both are less than equals to 0. So if this is positive, then the product will also be greater than equals to 0. Again, if this is negative and this thing is also negative, minus minus will also make it greater than equals to 0. So we need to consider each of the case separately, right? So let's do that. Let's consider the first case. So this particular expression will give us this, and if you draw the real line, what do you see? Here you have say 2 and here you have minus 4. So this expression is saying that x is less than equals to 2. X is less than equals to 2 and x is greater equals to minus 4. X is greater equals to minus 4. So what is the common part? This thing is the common part, right? So if you combine these two expressions, because you have and here, what you will get? Minus 4 less than equals to x less than equals to 2. This, right? So this is the common part and we are writing this in a combined form. So it will come out to be minus 4 less than equals to x less than equals to 2. Now if you take a look at the second case, it will be 2 less than equals to x and x is less than equals to 4. Again, if you draw the real number line, put 0 here. Sorry, it will be minus 4, right? 4 plus x is less than equals to 0, so it will be x less than equals to minus 4. So this particular expression is saying x is greater than equals to 2, so this part, right? And x is less than equals to minus 4. Now is it possible that for any value of x, x is simultaneously greater than 2 and less than minus 4? It is not possible, right? Here we can do this because there is a common part, intersection portion. But here there are two distinct regions and one particular value of x cannot be in two distinct regions, right? So this case is not possible. This case is not possible. So we eliminate this case and we say that the domain will be only this. This will be our valid domain. I hope this process is clear to you. So whenever you have the product to be made greater equals to 0 or less than equals to 0, you have to consider particular cases and check the domain for each of those particular cases, and that will give you your final answer, right? I hope this is understood, and these are some homework questions which I want you to do in your free time. You can take a screenshot of this. You can pause the video and take a screenshot and let me know in the comment section what you get as answer, and in the next video we will solve this question and move ahead to understand the range of the function, right? I hope you find this video helpful, and let's meet in the next lecture. Thank you for your time.